Okay, and t-test requires assumption. T-test is a parametric test. What does it mean, parametric test? Parametric tests require certain shape in data distribution, and which require normality. Okay, so when you look at the distribution of data histogram among deceased, this is important to look at data differently within the group. You don't combine the two groups, and then you draw Y, total hospital cost, and then both have to be normally distributed. So that's the assumption of a t-test. Okay, and here variance of outcome variable is equal. Well, we are using a Welch test, so variance can be unequal, so you don't have to worry about this. And all the observations are independent. That means you cannot have more than one observation coming from one patient. So if you repeatedly measure data, so one observation, 2 or 3 or more observations are coming from the same patient, single patient, you can't use student t-test. Okay, so make sure you have normality assumption and independent assumption are being met. So in R, actually the histogram in R and U combine survived disease together, so I didn't want to use it. So instead I use box whiskers plot. Box whiskers plot, this middle value is a median value. And then this point is 75th percentile, and this point is 25th percentile. And then these are outlier. So by looking at this, and you can tell data are skewed to a small value, but then have a large tail to the larger value, right? And in survived, and also in deceased. So median is not really falling in the middle. And then these whiskers are not symmetric. So this indicates data are skewed. So make sure you look at data separately for survived and deceased patient. And then, therefore, in fact, using t-test in this form of data is wrong. So you can't use t-test. Really, what does it mean? You shouldn't be believing this p-value. Okay, if the data assumptions, if the test assumptions are not met, test could be invalid, so you should not be using a p-value result from such invalid test. So what should we do? So many people might convert or transform data to make it normally distributed. So this data you have, if I draw histogram, data looks like this, right? Majority of data are small value, but you have a longer tail to the higher value. And so that's total cost. Okay, and this type of skewness, log transformation might work. Good. Okay, so let's try log transformation. And I'll show you how to transform data in R. But all you do is, here I'm using natural log transformation and create a new variable. Okay, and after, you don't have to worry about use log of E or log of 10. Statistically, the p-value would be the same if you use either one. Okay. So let's look at distribution. After you log transform data, actually you have a nice normally distributed data. You have one outlier, but that's okay. The median is falling in middle of the box, and whiskers are symmetric. Okay, so this have a good normality. So after you transform data using a log transformation, and you can use student t-test. So let's redo student t-test, and after I do t-test, redo t-test, p-value actually become highly significant. So now it's less than 0.05, much less than 0.05. So therefore, we have evidence showing a difference in total hospital cost between two groups. And here you have to be a little bit careful. And what is this? This is average log cost in survived and in deceased. And log of the cost is hard to make interpretation. So you actually better to anti-log and put it in original scale. And how can you anti-log? Since we use log of E to begin with, and I do exponential of 10.16743. Do the same thing here. Log E. I use log E for that, so exponential of 10.71721. Okay, and let's do computation. 10.16743. Right, so after you exponentiate, and this one 26041, this 45126. Okay. And this is, we call it geometric mean. Okay, which is actually very close to median value. So when data are skewed and mean value is pulled toward outlier, right? So mean value in this case, without log transformation, was much higher than 20-something value, right? 46, and then 61,000 in deceased. And although those are pulled by outliers, so if you take a log and anti-log of that, that gives geometric mean, which is close to median value. Okay, so you could, instead of compute median value, and use a p-value based on the log transform t-test, and that's one thing you can do, or you can show your data as geometric mean. Either is correct. Here is a descriptive data, and here is a median. So as you see, geometric mean 26,000 is close to median of 27,000, and geometric mean of 45,000 in deceased group is similar to 47,000. So these are medians. Okay.